Today's pretty nice, though, because in section 4 or 5, we're going to finally hit on your favorite equation in all of algebra and all of like last year, is the slope-intercept form of a line, which is everyone's favorite pre-algebra equation and algebra 1 equation. Wait, weren't we already working with this? You learned about it last year. We haven't really used this so much. We said this was something with slope, but it wasn't exactly slope. It has a slope in it, though. Whatever m is the slope of the line. Whatever's multiplied to x is the slope of our line. And then this thing that's added on is the y-intercept. Which is awesome, because if we can rewrite our equations in slope-intercept form, then we don't have to use that slope formula. We don't need to know points in the line. We don't need to know any of that stuff. We can actually calculate the slope by just reading it off. It's whatever is multiplied to x. And the y-intercept, where it crosses the y-axis, is whatever is added to the equation. So we can actually find slope and y-intercept by just doing solving for y, like the 3 equations down below. Let's identify the slope and the y-intercept of these given lines. Well, the easiest way to do that is solve these equations for y. So if I want to get y by itself, the first move I can make in this is, how about we subtract x from both sides? And get 3y equals, I'm going to write the minus x first, because that's the same form as mx plus b. I want the x's first. You don't have to, but it's a nice standard form. I need to get y by itself, so my next move, Jack.
It says y-intercept, so find out.
We'll see that finding the y-intercept is actually really easy. For here, our last move to get y equals is divide the left by 3. So we divide everything by 3. And you get this equation. Y equals negative x over 3 plus 9 over 3, which is just 3. We're not quite there yet, because slope-intercept form says we want something times x. And this is like x is in a fraction here. This is less than ideal. Well, let's think about this. What happens, what number is actually in front of this x if it's not written in? 1. Okay, so I claim that you could rewrite this as like y equals negative 1x over 3. These two things are definitely the same. So I'm just putting in that hidden 1. And if x is in the top, in the numerator, I claim you can also do this. Claim you can do, we can, instead of writing the x in the top of the fraction, we'll pull it out and write it off and write it next to it as though it were a whole number. Okay? I claim each of these things are the same. Well, if they're the same, we should be able to work backwards, right? So how do you multiply a whole number to a fraction? What did we do? When we multiply a whole number by a fraction, how do we set that up first? How do you multiply a whole number to a fraction? I'd put it over 1. Well, the whole number in this case is x. It's like not in the fraction. So if I put like a 1 under this x and multiply it across, you get negative 1 times x. And 3 times this thing over 1. 3 times 1 is 3. So these things are the same. Well, if you know this, then what's the slope of this line? What's being multiplied to x? Negative 1/3. What's the y-intercept? B. What's the value of b? What's the y-intercept in our equation?
3.
The y-intercept is 3. The slope is negative 1/3. You didn't have to plug in 0. You didn't have to do any of that stuff to find the y-intercept in this case. Because if we write it in slope-intercept form, it's just told to us. It's whatever is being added up. How about this second example? How do we solve this for y? What do you need to do to get the second equation so it's in y equals mx plus b form?
Nothing.
Allison, we said it a lot louder.
Nothing.
Nothing. It's already there. So how much work do you need to do to find the slope and the y-intercept? Like none, because it's already there. What's the slope of this line?
-3.
Whatever is multiplied to x. So yeah, so then to find the y-intercept, well, let's just subtract. So how about we change this subtract from the plus and negative? What's the y-intercept? This last one here is very similar to the first one. I want to see you do this on your own. 3x minus 5y equals 12. Tell me what the slope and the y-intercept are. And please do so by rewriting this in slope-intercept form. Okay. Slope-intercept form is going to help us graph really efficiently, really quickly. We don't need to make tables of values. You don't need to plug in 0 and find the intercepts. And everything is given to you if it's in slope-intercept form. So if I ask you to graph, these equations that are in slope-intercept form, I'm telling you a point. One of the points that's being told to you is the y-intercept. Where do we graph y-intercepts at? Like where on the graph is it? The y-axis. So if you know the y-intercept, we put a dot on that spot, the y-axis. What's the y-intercept of this equation? 5. So let's put a dot at 5. 1, 2, 3, 4, 5. What's the slope of this equation?
-2/1.
Slope tells us how the line changes, what the shape of the line is. Slope is change in y over change in x. Some people remember it as rise over run. So this rises by -2. How do we rise by -2?
Go down 2.
So start at this point and go down 2.
Then over -1.
1 is positive, so we'll go +1.
Wait, but isn't it like the whole thing? Like not just
Down 2, over to the right 1. Oh look, 2 points. Draw a line. Also, I said label it. What I mean by label it is tell me what the actual coordinates of those 2 points are. The coordinate of this point, we went left and right 0, up 5. We went right 1 and up 3. X comma y would be a good enough label for this graph. If I want to graph this second line, probably the easiest method, if we want to graph this using the same method, we're going to need to rewrite this equation so it's in mx plus b form. Y equals mx plus b, slope-intercept. It's not in slope-intercept right now. So let's rewrite it first. 2y equals -x, so subtract x from both sides. Divide everything by 2. Y is equal to -x over 2 plus 2, which by the same idea we had at the beginning of the notes, said that -x over 2 should be exactly the same as -1/2 of x plus 2. This will tell us exactly how to graph. Plot the y-intercept. It's at 2. 1, 2. Use the slope to find a second point. Rise over run. Down 1 to the right 2. Down 1 to the right 2. Draw a line. label the 2 points. Left and right 0, up 2. Right 2, excuse me, up 1. And you're done. Oh shoot, that was a lot bigger than I wanted. Okay. What's nice about parallel lines is that this fact is definitely true. Is that the slope of 2 the slope
Left J. J no.
the slopes of 2 parallel lines are equal. We have a nice story problem that goes along with all this stuff. Okay, on the back side it says you can use a laser or inkjet printer to print an 18-page report. This laser printer will print 6 pages per minute, and the inkjet printer prints 4.5 or 4.5 pages per minute. The number of pages remaining that have not printed after t minutes is given by the following equations, the following models. Pages left to print is equal to -6t plus 18. And for the inkjet printer, the number of pages left to print is equal to -4.5t plus 18. This should make sense, because if you haven't spent any time printing, how many pages should be left to print? How many pages do we have to go? How many pages are still left to go on the report, sitting on your computer not printed? All 18 of them. So if you've spent 0 time printing, then you still have 18 pages left to go. If you spent 0 time printing, you still have 18 pages left to go. Okay. What, these equations look like they're in like mx plus b form, y equals mx plus b. Which one of these variables, p or t, are we going to represent with y? P. So that means when we graph, eventually when we graph these things, the p, or pages remaining or left to print, are on the y-axis. So then what goes on this axis, the x-axis? Time, and it's in, I believe, from the problem, it's in minutes. Good. Let's graph each of these 2 equations. Let's graph these. And then we're trying to find how many minutes do you save. So we'd like to know how much time it takes to print all of these. We'd like to know how much time it takes to print. Well, how many pages are left when you're done printing?
0.
0. So we'd really like to figure out where these lines are when pages are 0, when we're on this line somewhere. So let's graph each of those 2 things and figure out where it crosses the x-axis here. Well, they're in mx plus b form, so we should be able to graph each of these. If the laser printer is on top, it has a y-intercept of 18. It has a slope, because it's multiplied to the thing we're calling x. The slope is -6. -6 over 1. The slope is -6 over 1. So I'll go down 6 into the right 1. And notice these are counting by 2's. So 2, 4, 6 over 1.
So won't they just mean 18?
They will meet 18, but I don't really care where they meet here. I want to know where they're at when they're here. Draw a line through them. And keep drawing my line until I get all the way down to when the pages are 0. I go down 6, so each box is counting by 2s. 2, 4, 6, to the right 1. And you keep going. 2, 4, 6 to the right 1. 2, 4, 6 to the right 1. Draw a line through them. And your line ends up hitting right here. With the inkjet printers. The inkjet printers has a y-intercept also of 18. So you still start with 18. This time it has a slope -4.5. Like over 1, or 4.5. Well, we can still handle that. We can still handle that. So that's just telling us go down 4.5 and go to the right 1. So we'll go down 4, 2, 4, and a little bit more, and over 1. It won't be exact, but we get a pretty good estimate. Draw a line. Down 4.5, so 4 and a little bit more, and over 1. You go down 4, so 2, 4, and a little bit more, over 1. 2, 4, and a little bit more, and over 1. 2, 4, a little bit more, over 1. And we get a line. If you connect all the dots, it looks something like this. How much time does it take for the laser printer to run out of pages to print? When there are no pages to print, it's taken 3 minutes. So the laser printer takes 3 minutes to print. When there are no pages left, there are 3 minutes gone by. How about the inkjet printer? It takes the inkjet printer 4 minutes to get to no pages left. So how much time do you save if you use the laser printer? You can subtract the 2 and you can save 1. Save yourself 1 minute. Last but not least, we're going to use this idea of parallel, which determines which of these lines are parallel. If you want to know lines are parallel, then from that definition, that means we need to know their slopes. And we want to know if they have the same slope or not. So you have a couple different ways to go about doing this. You could either, A, use the slope formula to find the slope of each of those lines, y2 minus y1, x2 minus x1. Or maybe you could graph each of those lines with those points and count boxes and use rise over run. Whichever one is easier. I think the counting boxes is a little bit easier, so considering I gave you graph paper. So line A goes through 0, 3, left and right 0, up 3, and 3, 1. 1, 2, 3, up 1. What's the slope of this line? How do we find the slope of the line through these points with a piece of graph paper? You can count boxes. Rise over 1. Change in y, change in y's over change in x's. How does the y change? Down 2. Slope of line A. Down 2 and to the right 3. Line B is -3, back 3, up 3, and right 3, down 1. Draw a line. This line kind of looks parallel to this one. We need to know for sure by checking the slope. 1, 2, 3, 4. So we'll go down 4. 1, 2, 3, 4, 5, 6. Down 4 to the right 6. Are those two things the same? Two goes into each of those? Yeah, those two things are the same. So their slopes are equal, so these lines have to be parallel. Let's plot line C. Negative 4, 0. So back 4, up and down 0. Left and right 0, down 3. We'll draw a line. And what's the slope of line C? From here to here, we go down 1, 2, 3, and to the right 4. So the slope of line C is down 3 to the right 4. Are lines B and C parallel? No. Why not? Because their slopes are different. B and C are not parallel. A and C are not parallel. A is parallel to B. Parallel symbol being two parallel lines.